I'm starting up the stream. Should be going any second now. Looks like the stream is running. Hi everyone, I'm TigerHawk3, and today we are going to continue and possibly finish the Python Deque implementation that we've been working on for 8 segments previously. This is part 9. So, all we have to do now is slicing. So, first thing we're going to change none type isn't built in as a name, like list and int, etc. are, but you can just get the type of it, and we can take out this thing. That's a little cleaner. Part int type none, etc. So if anything in here is not an integer or none, then we raise this error. If step is 0, that is a value error. Raise value error. I said in the previous segment that we would be okay with 0, but we're not. We're not doing that. Raise value error. Slice step cannot be 0. Okie doke. Okay. This stuff, this thing, this is wrong. What we actually want to do is, if someone passes an explicit integer for a part of a slice, then we use that for it. But if they have none, then we need to look at the direction to see whether it should be the beginning or the end. So if start is none, start will instead get 0 if the step is positive. Otherwise, it will be the end. If stop is none, the stop will be self.quantity. If the step is positive, otherwise we want 0 because we're going backwards. Okay. This should give us actual values. So at this point we know that we have integers. We've taken out the none. We've taken out other unacceptable values. So at this point we have a start index, a stop index, and a step value. This is good. We will need these things. So, I think we will be writing a few helper functions to do basically what getItem, setItem, and delItem actually do. Like this stuff. Delete actually is probably good to put into a function, because we do that elsewhere. Somewhere. Where? Gotta find it. Insert, I think it's remove. Why do I need forward at all? Oh, to see the before and after. I think remove does something like this. Where's remove? Move, replace remove. If it's remove, if there's a prior, Well, we say if there's a prior one. This is actually kind of better, isn't it? But how about first and last? Does this change first and last? I don't think it does. Oh, yeah. If there's something before, then the before's next one is this after one. And if there's nothing before, then this is the first. And this is what we'll want to do. We are going to define a remove node. Remove node. Self and a node. Remove node of and we're going to send it this node. Quantity minus equal 1. I think we will include that because it does have to take care of that part. All right. Okay. So we pass it a node. If there's something prior to this, then that prior one will point to the one we have our node. If there's something prior, then it will now point to the next one. And if there's something after, it will point to the previous one. And if there's nothing before, then the next one is now the first thing. And if there's nothing after, then we take this out and the other one is the last thing. So, very good. Let me just pass it the node. Okay. And insert, remove node, just need the node. Del. Okay. This should just be current is the one we want to remove. Remove node current. There we go. That helps. Okay, so we have a way to remove. Replacing is easy. It's just set the element to the new value. And so we have del. We have set is easy. Get, in this case, a slice of a deck is going to be a smaller deck. Sub 0, start as none, stop as none. Now we have values. I'm gonna... yes. What if the... If it's none, we will still need some of this stuff. This and that. Important. Okay. I think the rest of this, no, go away. So, and we can take out this comment because we're working on that. If it's not an integer or none for everything in here, then we say it has to be an integer or none. And then we assign to local things, easier. If the step is 0, that's bad. If either of these is none, we get the start means the beginning, and stop is the end, unless it's a negative step, in which case we want the other side. And now we normalize those indices, whatever we got. If we have, 0 or the quantity, then we just, kind of stick with that. Norm index, if I give that the quantity, which is not a valid index, that, okay, it stays there. So we can indeed identify being after any item. That's good. Okay. So that was the easy part. Now, how do we actually want to implement this? That's a good question. Should we make an iterator and then do next a bunch of times, or keep track with just having an int? We could do while I think I'm going to change the step. Should I change the step? If we're going forward, then the start is smaller than the stop. Otherwise, it's larger. Can we normalize that? My current algorithm I'm thinking of is just keep incrementing start until we get to stop, and checking step. Or like zip or something. Because we were past possibly an element, and the element could be an iterable of some kind. So oh no, that's for set. And that element could be an iterable, in which case we would want to go through it. Maybe we should let's do the following. If the choice is set, let's do get first. If choice is get, and I'm going to do an elif because I feel like it. Do I need anything for delete? I don't think so. Let's not do that yet. So if it's get, we will be getting a slice of the deck, and we need to create a new one. Equals type self and call it. Oh, one other thing that I wanted to change. Passing one object reference to a function is a lot faster than passing then unpacking an object reference into many object references and passing that to a function. So this thing is gonna change. And there's more. There's more. And there's a type self somewhere. This thing. So this won't actually work. But we can do that. Pass itself and create a new deck out of it. Okay. Where else do I do that? Nope, nope. This I'm gonna do stuff with. I know there's more later in the add. Nothing. Instead of star self and star other, yeah, add is going to have to be let's do the following. Result equals type self. Maxlen equals self.maxlen. Okay. For I in D in self and other, for I in D, result dot append I, and then we will return the result. Because this is not a thing anymore that we're gonna do. So it was a nice little one-liner, but nope. So we make a new one with the maxlen for each deck in this one, and then the other one for each element in whatever deck we're looking at. We append the element to the result, and then at the end we return it. Okay. Actually, we can just do dot copy, right? We can copy it and extend it, I believe. Where do I copy? Here. Type self, yeah. And it is a shallow copy, that's fine. We're going to copy it. Result.extend other. And then return it. Great. That's good. We make a copy of this, and we extend this copy by everything in the other one. Return that. Okay. That's good. Contains mall. Where else do I do this stuff? I don't remember. Okay, I don't think I do it there. That should be it. Oh, and here, of course. Okay. Let's save this and see what happens. Oops. I was writing stuff and then I kind of stopped in the middle, right? While this thing. We're not there yet. There. Okay, cool. Zero, 1, 2, 3, 4, and it took out number 4. Okay. Didn't test everything, but I really don't care. And someone is in chat. JC says, would it be possible to say deque.maxlen, or does self have a specific function? And hey, by the way, hey. Deque.maxlen. Self does have a specific function. Self refers to whatever instance of this class that we're working with. Whenever I say self here, that is a separate instance that the class is just referring to. You can also do, we have a class A, and this, great. So now we have a class, and we can say a.test, and that's 0. Another thing we could do, because A, open and close parentheses, instantiates the class, which means make an instance of this. If we want, we could just call it on the class itself, and it has that, you know, test function in it, but now it is expecting a self, the instance that we want to work with, and that is, we don't have one. A equals A. So now we can do a.test, and we pass it A, and we get 0. If we just did a.test, it will complain at us, because it's expecting the instance itself. If you want, you can omit self entirely, and then it will not be expected that you pass an instance of the class to it. This is also called a static method, and then you should probably decorate it with the @static method decorator. So yeah, self is whatever instance you're working with, and there can be multiple instances, so it refers to whichever one you're working with. So instead of deque.maxlen, the deque that we're interested in is called self. If we want, we could say, we could have called this something else other than self. It doesn't matter. It's just convention that we call it self. And then we would say, you know, whatever name we call this instance that we're working with, dot quantity is equal to whatever name we gave it. The name itself is arbitrary, but the first argument is representing the instance itself. So, and the instance dot method name is just short for class dot function name and pass an instance. So we could do like down here, instead of doing, we don't really do that anywhere. This is all magic methods. If we had d.copy somewhere, we could have done dq.copy and pass it d, and then it would know that we want to make a copy of our particular deque d. And if we had multiple different deques, then we could say dq.copy, you know, whatever instance we wanted, d, or, you know, h if we had an h deque or something. But it's shorter to just do d.copy to call it on an instance. So that is self in Python. This thing. Okay. This is not done yet. If choice is get, Then we instantiate a new deck. If we want to set to something, then it equals an iterator out of what's it called? Element. Because element isn't just one element, technically it is. It's a reference to a single object, but this object contains references to other objects. So we're going to send it to iter, so we can call next on it a bunch. Actually, maybe we should just use zip. No, we'll use both. And then we skip a bunch. Okay. And now we will do for. Do we want to just get an iterator and start at the beginning? I think we might want to have, we'll just get the node with neighbors. Where are the neighbors? We still want to do that. Okay. Equals self.neighbors, and what index do we want? We want the start, is the first one. Okay. Now, if the deck is going forward, meaning self.forward is set to true, and our step is positive, then we want to go forward. Or if both are false. Let's if we're going forward and the step is positive or not, self.forward or step more than 0. So if we're going forward and positive, or we are neither moving forward nor do we have a negative step. So if we didn't have forward, then going forward through the list would mean using prior a bunch. But if the step is also negative, then we actually do want to use next instead of prior. So this is the forward case. Something else. Great. If we're going forward, about, I think we might check the choice again. If choice is get, do we want this? I'm not sure. What is the actual best way to do this? There are just so many. Because first I have to get to a certain item. Do I want to go forward? Do I want to go whichever way the slice goes? So if I have a deck that starts here and ends all the way there, and I want this bit, do I want to, and I'm going forward, do I want to go all the way through it and then grab this bit? Or do I want to get this and then go forward? Maybe my iter method can take a different, can handle a custom node. Maybe that would be good. Current self.first. Okay. This is what we will do. Self node equals none. If node is none, current equals self.first. Let's just call it current. So this way, we can just pass it a node and do that. Rev iter also current equals none, and then if current is none, we start with last. Great. So now we can use these iterators and pass a specific node, and it will continue to iterate. Good. Why didn't I do that earlier? Would have been good. Anyway, okay. Going forward. Our deck that we're gonna go through, that it's not self, it's a fragment, is gonna be self.iter. Actually, we don't need to do that, right? Because this is switched when we reverse, isn't it? Reverse switches these, yeah. So if step is positive, current else deque equals self.iter rev iter current. Great. Okay. So we have our starting node, and that's current. There's going to be off by one errors here. Just letting you know. We're not going to use this anymore. It's going to have to change the testing a whole bunch. Equals list of that, blah blah. Print. Let's do this. 4 slices in none, none, none. Setting up a test thing. Do I check for the step being none and then give it 1? I should. Yeah, I gotta do that. If step is none, step is 1. Okay. Forward, back. For node and value in, now we're going to zip. The deck. Do we actually want this? No. First, we're going to check what sort of thing we have. If choice equals get, because with this, we're not interested in the element. So for node in the deck iterator that we have, result dot append this node, and then we want to skip a bunch. Nothing in range. Let's make the step normalized. Okay, so it'll be positive. For something in range of the step -1, because if the step is 1, then we don't want to do this at all. So we'll have a range of 0, which is nothing, right? Yeah. Okay. We want to skip something in this deck. And if we get a stop iteration, I don't know, break. That seems fine. Look at this gigantic function. This one thing is very large. That's okay. Sometimes it happens. If we run out of elements to do stuff with, then that's it. And after we do that, we want to return the result. Where is our, yeah, I want that. Get, set, no. Because it could be del, but we don't have any setup for del. That's okay, never mind. If the choice is set, this one's going to be more complicated, because the set slice method can change the length of the iterable sometimes. Not with an extended slice for lists. Do we want ours to be the same? I don't know. The way they ensure that an extended slice doesn't change the length of the list is by exhausting whatever iterable you passed it. And like my list, some slice notation equals some iterable. It goes through that iterable. If it has a length, it uses the length, I think. Otherwise, it just goes just goes through it, exhausts it, and sees how many there are. Probably turns it into a list or a tuple or something. Which I don't really like. It's something you have to be careful for. And to be honest, it makes sense that that would be an error, because L equals list range 20. What's L? We have this. Let's say we want all the even numbers, every other number, to be some other value, -1 or something. I don't know. So we would do L. So this is starting. We have a positive step, so an empty start means 0, an empty end means end of the list, and 2 means every other. So we are changing every other element, and let's say we have a list of length 10, range 30, 40. And then what's L? It should be 30, 1, 31, 3, and indeed it is. But what if we had like 50? So instead of only going to 39, this is not quite enough. I want that over there. I want this a little more. There we go. So instead of 39, what if there's more? We know we put the 30 here, and then we skip one and put that there, etc. and so forth. 39. What if we then have a 40? I suppose it'll go after the 19, right? How about 41? After that, it won't be, you know, every other item in that case. Should it just pile up afterward? 30, 1, 31, 3, etc. 38, 17, 39, 19, 40, 41, 42, 43, 44, etc. all the way to 49. Because then you don't have, like, something from 30 and then something from not 30 alternating every time. So you're not allowed to do that. Because what exactly are you supposed to do? And if you had it in the beginning of a list and weren't doing the whole thing, you can't do that. What if we had L only to 5, 2 equals range 30 to 50. If we had something valid, then that would be 33, I believe. And then L, instead of being 0, 1, 2, 3, would be 30, 1, 31, 3, 32, 5, etc. 5, and then it keeps going. But what if we had more stuff? Because the way it works without an extended slice, you can do this, because it's not an extended slice, so it doesn't have, the step is just 1. And this just says this block of items is just thrown out and replaced with another block, which could be larger or smaller. And that's fine. 30, 31, 32, all the way to 49, and then we have, you know, 5, 6, 7, right? Because it went all the way to 5. and ended just before 5, so it ended just before 5, and that's what we've got. But what if it was every other item? Should it just pile a bunch more over there? Or should it continue to alternate between, you know, every other item? We don't know, and that's why it's an error. And that's frequently why Python will produce an error for various things, because it doesn't know what it's supposed to do, and neither do we. That behavior is undefined, so it produces an error. But what will we do? I don't know yet. Get set del. And now I do want that, just in case. I don't really think it makes a difference, but I want it. So if it's delete, for node index result, no, not result. We have our deck that we're going through. We want to delete this one. Dot remove node, this node, and then for nothing in range, step -1, get the next one. And we also want to handle that stop iteration. Stop iteration is just going to be break, and then we're done. Maybe these will work. It's the slice assignment that could be messy. So what is our testing going to be? Print. We have our deck. Let's just do this equals if they're not equal, I could just do assert. It's for testing, right? That's the idea. Assert we will need to change these to something else so we can compare them. Otherwise, we can't compare them. -1. Okay, let's start with that. I don't know. We'll probably fail horrendously, but let's actually find out. I forgot a thing. 169. Logically, in terms of what's required for it to make sense, the colon is superfluous. But the language designer thought it looked better, so now they are required. None type and int. Step 0. If step is none, oh, I should do oh, I referred to the step. Let's let's do that first then. Okay. Reassign that. That's great. Needs the items. Okay. It's because taking out the star from here, we can no longer send it just nothing and have it create an empty one. So, assertion error, it's wrong. So let's do the following. Print this and that. What the hell? You really ought to spell things right, or it doesn't work at all. So now we will just print them. That is not super useful. Let's get something shorter. Oh, I want the element, not the node. That's why. Okay. Because I have nodes here, I don't want that. But it is A, B, C, D, E. E, D, C, B. So that's good, but it has to be the element. Or else, no worky at all. Append. We don't want to append the node. What kind of crazy talk is that? There. Beautiful. Compare those for us. True, true, good. That's a relatively minor error. Del. So we have forward and back. Before we do other stuff, let's make this I want to actually see the thing. Okay. Comma, chameleon. 53 minutes. We're doing pretty well. JC in chat says, it's always the little things. Yes, indeed. Especially in this, everything is little things. Off by one here. Forgot to go the other direction there. Etc. And so forth. A, B, C, D, E, B, C, D, E, E, D, C, B, A, E, D, C, B, A. So now we have that. That works. How about to some arbitrary point? Let's just do 3. Doesn't matter. So this will do only 0, 1, and 2. So it should be ABC and something. I'm not particularly clear on it, but maybe it'll work anyway. So this is incorrect. How does slicing work actually? Oh, I forgot to say if the element is past the thing, then we have to stop. Duh. I think we will have to keep track of that. Instead of making it the absolute value there, we will do that here. Because then we will want to do start plus equal step. And then if the step is negative and if the step is positive, then start should never go past end. If it's negative, start should never be smaller than end. If step more than 0, if start more than step, break, else if start less than step, break. If the step is positive and start more than step, or step is negative and start less than step, break. Okay. I sense code repetition, but we will see what happens. Off by 1 error. See, this is what I'm talking about with the A and B instead of A, B, C. Let's move this. Afterward. After, before, something? We already are. More than... No, start more than stop. All these words sound the same, I tell you. This is the problem with copy pasting. You make a change somewhere and then you have to copy paste again. What happens here? ABCD, ABC. Let's do this part first, shall we? Before we do the append or removal. ABC and ABC. Going backward, we get E and then D, but I didn't want that. Still too much. Let's give it, instead of 3, let's say 2. NAB, EDC, ED. So we're going one too far when it's negative. Where am I? I think it's this thing. It's gigantic dealy. Okay. This is what we call monolithic, because it's a giant block of text that's one method, and it's terrifying to work on. This, that. If it's negative, we're stopping too late. Let's do this. Does that do it? Wrong way. This one was fine. Just one other way. Huzzah. I can't really tell you what I did, because I don't particularly know. I just saw there was an off by one error, and started moving things around by one. And now it's more correct. Great. Let's try 4. Wrong. Oh, no, that's not wrong. Never mind. It is correct. I'm like, something empty, that's terrifying, that's bad. No. It's supposed to, they're both empty. A, B, C, D, A, B, C, D. Maybe a negative index. I don't know. I don't know, man. Both the same, E and E. Ideally, I would have a whole bunch of random slices, and I would do things like that, but I'm not gonna. Del D. So it should delete 0 and 1. No. This is what I wanted. And then print D and E. They should be the same. CDE. JC in chat says, "Oh, progress." Did you know that the national motto of Brazil is order and progress? I mean, in Portuguese. They don't have an English motto. That would be weird. They're not doing super well in that regard nowadays, but it's their motto. So that's what they go for. Anyway, del about from the end. Every I don't know. Just A B C D E A B C D. Ooh, that's wrong. That's wrong. Fail. Delete every negative other one. Oh, because I go to... Oh, I do 0 and 1, but negative every other one. What does that even mean? What did I write here? A slice from here to index 2, from the end to index 2, going backward. So that means from here, every other, but only to index 2. 0, 1, 2. Maybe it's the delete thing has to happen first. Have to find it. There we go. Delete. Let's do that first. Now it happens. ABCD, ABCD. Okay. What was I testing before? Just 2. Is that wrong now? Yes, it is. Awesome. Delete something then checks. I think it should not delete something and then check. That seems wrong. Let's go with this version. See what happens. CDE. Okay, that trims those two. And then what happens? Should have gotten rid of from the end to 0, 1, 2, not inclusive. So it should have deleted the E. And then D. Then left that, and then stopped. Why didn't it delete the initial E? I think it does have to remove it first. I think that does have to happen. Ooh, maybe if we move this part first? Yeah. ABCD, ABCD. Now that part's wrong. Okay. First thing we do, it's got to be because getting worked fine. That was working. Deleting is not working fine. Oh, because deleting things moves things down the list. Ooh. Yeah. How does that even work? Adam in chat says, "Hey, how have you been, Tigerhawk? I have been okay. Doing Python stuff. If we delete an item, we remove a node, and then, because this is modifying our data structure as we go over it. That's hazardous. What then? What does happen then? That still has a reference. Maybe if we just do this? I don't know. BD instead of CD. What the heck? Let's add some more stuff. So the correct thing to do when deleting the first two is delete the A and B. This just deleted the A and C. And the I. No, there was no I. H, G, F, E, D, C. Something is messed up here in a big way. Let's put that back and see what happens with the larger structure. That works properly when we do that. Does that work properly? Yes, it does. AB, AB, okay. How about if we go backwards? Should have been empty. Something is wrong with stuff. Something with the way we're removing nodes as we go over them. That's wrong. Should have removed everything. How do we remove things? I don't really know. I want to remove an item without breaking iterations. I'm trying to iterate through something while modifying it. That's generally an awful idea. Adam says, I've been reading and working through the Python official guide. I really enjoyed it so far. Good. The official Python tutorial from python.org is very, very good. And I think this issue we are seeing is due to modifying the deck as we go over it. So let's do the following. Shouldn't we start with that node and then do this? Let's start with this. No. Can do this afterward. It should be after. We start out. If we have to stop, then stop. Okay. Let's change this to something else. D E A through H, A through H. Can't really see everything, huh? There we go. Adam says, can you elaborate on why modifying the deck while going over it is a terrible idea? Like modifying any iterable as you go over it. because when you loop over it, you're expecting to get certain items in a certain order, and if you start removing things, it might change the way it goes over stuff. So that's there's more explanations on mutating an iterable during iteration online. There's it's not just the Deque object, it's generally lists, because those are mutable, but also like sets, etc. Generally, when you go over it, you want to keep it like that. One little trick is if you have a list, my list, and you want to remove any element that is smaller than 5, or I don't know, whatever. Instead of going for item in my list, if item smaller than 5, my list dot remove item, that can cause a mess. So what you can also do instead is for item in my list, and you just make a slice to make a shallow copy of it. But of course that doubles the memory that your list takes up. It doesn't actually duplicate the entire object for each element that it holds. It just has to have twice as many references. You can also delete from the other end. If you're going forward, you can remove from the end, that sort of thing. But yeah, A through H, A through H. Does this still work? Invert the order. H, G, F, E, D, C, B, A. H, G, F, E, D, C, B, A. Okay. About -2. HFDB, HFDB. Let's put this on 2 separate lines. No, not that. Just this. That's a little easier. And make this one a list because it's easier to compare that way. About +2. ACEG. About starting from 1. Good. Start from -1. Testing, testing. Those are looking pretty good. I have to call it. HGFEDCB. Oh, this one includes the A. Why though? We start at -1. So we start at the last item, and then we keep going. But mine cut off a little early. Cuts off a little early. So first we check if it's valid, and then we increase it. So if we started from -1 to 0 is, I guess, what the equivalent would be, right? Yeah. We start at the end, so that's h, so we get h, f, d, and b. Start h, that's -1, and then we add -2 and get -3. -1, -3, and then -5, then -7. No, -1 is considered. We get the normalized. Let's print what we have. Let's do that. Start, stop, and step. Each time we begin. So we have 7, 0, and -2, 5, 3, 1, and 1. Do I need to do something else with step somewhere? If it's the -1 that isn't working. The others, positive direction is working fine. Negative direction, not so much. One is 1 less than stop minus step. 1 isn't less than 0. Stop minus step. 0 minus -2 is plus step. Maybe it's that. That's the result I wanted. Adam asks, which of all the programming projects you have worked on was the most enjoyable to do? That is a good question. I don't currently have an answer. I can talk about them in general terms. The ones with a good result, I think. Most enjoyable to do. Like Tetris, for example. My Tetris implementation that we did on stream is pretty good. Good keybinds, it's fast, works well, feels responsive in general. So that's pretty good. I have a sliding tile puzzle, also on GitHub, that is good. It's fast and it works. I have a chess program that's very large. It's like 3,000 something lines, but a third of it is comments. And I have comments either above or below or next to every line of code, pretty much. Actually helped me find some bugs back in the day. Because I'd be, okay, I have to write a comment for this, and it's doing this and that, and why is it doing this thing? I shouldn't have done that. And then I fix it. For ABC in none, none, none. This is what I should have done in the first place. 1, none, none. None, -1, none. So I have everything. Cut one off here, cut one off there. Going backwards. Going backwards. Cut one off. From the beginning. Cut one off from the end. Adam also asks, which one was the biggest irritation? Ones that I didn't write in Python, basically. But if we limit it to Python ones, probably the idle clicker, because I ended up making lots of data of game content to test it on, like having way too many upgrades for stuff and levels because I needed to test large numbers. And then I had something that was a property to get the amount, but then I also wanted to add like a different style of achievement for like lifetime clicks, etc. It didn't work well with that, so I'm like, eh. Yeah, that bothered me, but none. Say +3. Let's start with that for a while. C equals E, A, B, C. This will probably fail. Let's see what happens. Oh, what I do wrong? Oh, I need that. Oh yeah. Not this. This. Yeah. Okay. That's a lot of stuff from the print statement I inserted over there. Let's take that out and do this again. False. True, false. So true, true, false. True, true, false. Okay. So what do we got? Oh, not this much. Sorry. A, B, C, D, F, G, H. A, B, C, D, E, F, G. Supposed to cut off the -1. H, G, F, E, D, C, B, D, C, B, A. Goes from the end and cuts off at, what happens at 0? Didn't I have that and it was right? DCBA, DCB. But none works, correct? HGFE DCBA, so that works. But then we put in 0. And it's supposed to cut that off. Let's do the following. More than or equal to? Will that break everything else? I don't know. If start is more than or equal to more than or equal to is what it should be. Step is negative and this. But one of these is the negative direction. So maybe less than or equal to. Hopefully this doesn't break everything else. A to G, A to G, H to A, H to B. HGF, EDCBA, HGF, EDCB. Didn't fix it. Any difference? No difference. Let's go back to all these. True, 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 true. False. This one still fails. Why? None, 0, and negative 1. So none, 0, and negative 1. So we have start, stop, step, none, so it's self dot quantity. Yeah, start from the end. And then we go until what? 0. None to 0, and 0 is given. So Adam says, I mean, out of every project in all languages, probably MIPS, everything in MIPS. It's an assembly language. It's icky. I don't know. Actually trying to write something in Julia, it's somewhere between a scripting language and a compiled and statically typed language. It's supposed, in theory, it's as easy to use as a scripting language and yet as fast as a compiled language. And in my use, I found it to be exactly the opposite. I found it to be very, very slow and bloated and annoying. Bloated, I mean like code-wise. I had to write a lot of lines of code to try to optimize stuff, and it just didn't really work very well. But anyway, none, 0, and going backwards. So None means we start at the quantity, and that's good. We end at 0, we're going backwards. What happens if I change this? I don't know. Hang on. Same thing. So let's do this. And let's take out these. Because this one works now, right? We have 8, 7. Supposed to print 8. Because it's 0, 1, 2, 3, 4, 5, 6, 7, 8. We want to print 8, 7, 6, 5, 4, 3, and 2. Or sorry, indices. Index 8. Eight, 7, 6, 5, 4, 3, 2, and 1. And that's also supposed to give us the A. Are we supposed to include 0 or not? I honestly don't know. No, we're supposed to exclude A. Right, but I'm including it, and I don't want to. Gonna add this back here. Yeah. Yeah. If the step is less than 0, yeah. When start is less than or equal to stop plus step, we break. 1 is less than or equal to... what? Printed this and it broke. Okay, that should be working. This is an off by 1 error somewhere. Because it goes a little too far. So we have start, stop, and step, and then start. Start has to be less, if start is less than or equal to stop plus step, we break. Here, start is 1, and stop plus step is -1. breaks. What in the... Oh, I have to print that beforehand, yeah. It's doing the same thing. When does that stop? So it just isn't. Oh, this happened. So it just... Nope. Where is it? Where is it? So it didn't stop because of this. Oh, that's only the exception. Okay. No, I don't want it there. I want it here. I think it's just finishing the entire thing. Yep. So this never actually gets broken out of, but it should have. Oh, Start. Step is negative, it'll never get there, obviously. So, how do I fix that? We have the stop. Has 1. Start minus 1. Less than or equal to something. Plus 1. I'm kind of just guessing here, because I'm tired. That's a bunch of... I didn't want a whole bunch of print stuff. Let's take that out of here. True, true, true. False, false. False. Now these are broken. Okay. This doesn't quite work, so we will have to come back to it. And I kind of expected slicing to be a gigantic mess, and it is. So, this doesn't work. Somewhere. I'm gonna put back the little oddity I did there. Take that out. When I make changes, if they weren't what I thought they would be, I take them out. Or else you're left with stuff that's that seems like maybe it does something. Let's say you have a code to do a certain thing, and you start adding stuff here to make it work, that doesn't do it, and then you leave that in there and add more stuff, eventually you will maybe find the correct thing to do, and there you go. And now you've got a whole bunch of extraneous code that doesn't help and might even do something wrong in some cases. So try to keep it to what you think it should be, and if you make a change that doesn't actually help, take it out. Or else you will have things that are there not because it seemed like the right thing to do, but because no reason, basically. Why are we adding step? Why are we adding step here? Oh, something else is wrong. I don't know. I really don't know. But, something somewhere is very unhappy. If the start is past the stopping point, then it means we're done. If the start is smaller than the stopping point, then it also means we are done. Right? Now it's these two that don't work. I really don't know. Oh, I don't wanna do that. There we go. HGF EDCBA, HGF EDCB, supposed to cut off an element. ADG, ADG. Oh, it's this one. False, false. And these were true and true. GF EDCB, GF EDCB A. So I have one missing from the first one and one extra in the second one. That's cool. Maybe it's to do with none. What happens if I put in 0 and then D? Next one. Then they work. It's something to do with none. The quantity should just be the stop. If stop is none, alright, -1. Maybe that will do it. Now other ones are wrong. That's great. That's great. Now this one and this one and this one are wrong, but these are fine now. No, not this one. This one. So none is not a happy thing. Let's take out all the nuns. Zero. Minus 1. 0. 0. D minus 1. 0. When D minus 1. Then they all work. Okay, something is wrong in the way we calculate what none should be. So that's that narrows it down, but the problem is none. Can we make this none? How about start with a positive step? Can we make that be none? That's good. D minus 1, none. Now it doesn't work. Should be quantity minus 1. Blah, blah, blah. Okay. If stop is none, it's self.quantity minus 1. If step is positive, else 0. If step is positive. If step is none, it changes to 1. And 1 is more than 0. So stop should change to self.quantity minus 1. And then it doesn't work. Here's what we'll do. Print the stop value. Let's make this, yeah, all true, okay, and then we make this none. 7 true, 7 true, 7 true, 7 false. So it was still 7, and yet it didn't work properly. Still ended up at 7. That's a little strange. I was going to end, but 7 true, 7 false. What? So in this one it works, in this one it doesn't. That's very strange. Wow. D minus 1 gets 7, and it works, and then it calculates it out to the same 7, and it doesn't work. What in the world? this is correct. But if we say none, it has the same result there, but if we say none, it should include the last one. What if we change this to the... Start more than stop. B through H, B through G. B through H, B through H. So it has the same 7, so of course it's going to do the same thing. What do we got now? 7 and 8. It's not supposed to have that H. More than or equal to? I'm really just guessing right now. Did I get something correct? Did it break everything else though? Probably. Because I think this is what we had before. But all of those work. I don't know if I've explained this concept before, but there is a programming methodology, kind of, not really. It's called cargo cult programming. In like World War II or something, there were like islands far removed from common civilization, indigenous peoples, and for some reason during the war these islands got airdropped supplies of food and whatever. I'm sure there's a real good explanation. Cargo cult. And what is a cargo cult? A millenarian movement first described in Melanesia. I don't know where that is. Oh. In the late 19th and early 20th century, that various ritualistic acts will result in the appearance of material wealth, particularly highly desirable Western goods, via Western airplanes. And this is from Wikipedia. Combination of crises, but like why? So anyway, for various reasons, Western goods, cargo stuff, may end up arriving at these localities, these regions, without access to the stuff, usually. And they try to find, how did we produce this result? And the answer may be, you didn't. It was because of outside factors and nothing you did made any difference. But they're hoping that maybe it did, and then they can do it again, and maybe it'll happen again, right? So maybe it's building a runway, or, you know, it's basically they're hoping that correlation implies causation. That something they were doing at the time might make the good thing happen again, and so they put in the runway ritual, or they have they may do whatever else. I don't know all the things that they might do. Maybe a dance or something, like a rain dance is a form of cargo cult. They think maybe if I do this dance, it'll rain, because sometimes they did that dance and then it rained afterwards, so then they do it again whenever they want rain. And cargo cult programming is trying to achieve programming results by putting in magic words and phrases, and like I've heard that, you know, if you have a while here, it'll finish my homework, right? So you have a while loop, and then your homework isn't actually done yet. And it really doesn't work. Doesn't work at all. But I just got a whole bunch of trues here, so it kind of shouldn't have worked, but then it did. So those work. Del D ABC, del B ABC, and then we set them, and then print plus D is equal to E. Does delete work the same way? Something's wrong. Must be integers. What did I send? I sent a tuple. When did I do that? Oh, no. Yeah, gotta do that. True. This is good. This is good. We can actually move this up here, and do that. Print D and E. If list D not equals E, print D and E. Should be no output. So that's working. After 2 hours. I don't even know what I did differently, because I thought I was just moving things back to how they were. Did I neglect any kind of test? Oh no, I need to change these to none again. How about now? Does it break now? It doesn't break now. Yep, now it's broken. A, B, C, D, E, F, G, H, A, B, C, D, E, F, G, H. What? 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 Well, let's do E, C, Oh, because it's just... Oh, no. I'm just printing the lists themselves. That doesn't help. What am I doing here? Delete. Yeah, I need these things. Yeah, but both of those broke. DABC and EABC. This is... no. Something's wrong in my testing. First I test the indices, and if they're wrong, then I do that. Then I delete part of it. Then I need to do that. Okay. If we slice and it's wrong, then print those slices, delete those slices, and if it's not a match now, then print what they are now, and then reset. Okay. That's very wrong. C A C D. No, it's supposed to be just A. Seven, 0, and -1 doesn't work. Where am I getting a 7? 7, 0, -1, -2. Oh, here's a -201. Oh, and here's the 7. Yeah. There should be no situation where they are different. So it still doesn't quite work. Somewhere. Something is still wrong. Possibly the same thing that was wrong like an hour ago. So, we're gonna be done today. And I will continue at a later time, because these are broken. None and 0 and -1. 7, 0, -1 would be this one. -2, 0, -1, this one. 7, 0, -1. This should be... these should be different some way. None, 0, -1. Oh, none, 0, -1. None, 0, -1. -201. 7, 0, -1. 0, none, -3. I don't know. I will try more stuff later. Gotta figure things out. How slicing works. Maybe I'll look it up. Maybe there's a Python implementation of list slicing. Just for kicks. Maybe I'll check that out, and maybe that'll work. So, thanks for watching this stream that went on longer than I would have liked. But I thought it was gonna fix it and make it good, but no, things are still broken. So, like, comment, subscribe. Join me next time, whenever that is. I don't know if it'll be tomorrow or the day after, something, at some point. I will have more stuff. We will continue this, because I really want to get slices done. I want to be able to slice this object. I want that to be a thing. The Python collections.deque doesn't do that, but I want this one to, because reasons. So I will put this on GitHub, even though it doesn't really work. And yeah, thanks for watching, thanks for joining me in chat, and I will see you next time. Have a good one.